All right, picture this. You've got two different hospital computer systems. They absolutely have to share life-saving information, but they were built by totally different people and, well, they don't speak the same language. So how do you get them to talk to each other perfectly without any mistakes? It's a huge challenge in software design, and you know what? It often boils down to one single question. Do you push the data or do you pull it?
So let's get into a real-world example to make this concrete. Here's the setup. We have one hospital, HKL, that's just swamped with lab work. Then you've got another one, IPR, that actually has some spare capacity. The big idea is to send some of those tests from HKL over to IPR. The question is, how on earth do you build that digital bridge between them so that it's not just reliable, but totally automatic and tracks every single sample without fail?
Okay, so here's how we're going to tackle this. First, we'll dig into the hospital handshake problem. Then, we'll look at the two big solutions, push versus pull. We'll see how each one handles sending a new test, and then how they sync a test's status. After that, we'll get into the architect's big dilemma, and finally, we'll reach the verdict.
All right, first up, let's really define what we're up against. We're calling it the hospital handshake problem. And you've got to understand, in a hospital setting, the stakes are incredibly high. A single dropped message isn't just an error. It could mean a delayed test result. So the goal here isn't just good communication. It has to be perfect, totally reliable, between two systems that were never designed to talk to each other.
For this whole thing to actually work, the system has to nail 4 key objectives. Number 1, absolutely no manual data entry when HPL sends a test over. It has to be seamless. 2, that new test has to just appear in IPR's system automatically. 3, every single status updated IPR, whether it's in progress, analyzing, complete, you name it, it has to get back to HKL right away. And finally, the big one, the entire process from start to finish has to be rock solid and traceable. We absolutely cannot lose a single sample.
Okay, so to solve this puzzle, the architects came to a fork in the road. They looked at two classic fundamental patterns for how systems talk to each other. And these aren't just slightly different techniques, they represent two completely different philosophies. We're talking about push versus pull. So, let's start with the push method. This is what we call event-driven. And honestly, the best way to think about it is like a town crier. As soon as something important happens, like a new lab test gets ordered, the system doesn't just sit there, it actively runs out and shouts the news. It broadcasts a message to a central place, like a message broker. And anyone who needs to know is already there listening for the announcement. Now, the pull method, it flips that idea completely on its head. In this world, we have a central system, let's call it Lisa, and it acts more like a detective. Lisa doesn't wait for information to come to it. Nope. It actively makes the rounds, going to each hospital system and knocking on the door, constantly asking, "Got anything new for me? Any updates I should know about?" This constant checking, this repetitive questioning, that's what we call API polling. And really, here's the simplest way to get your head around this. The push method is just like getting a text message notification on your phone. Ding! The information comes directly to you the very second it exists. The pull method, on the other hand, is like you sitting at your computer, hitting the refresh button on your email over and over and over again just to see if anything new has arrived. One is instant and automatic. The other is you constantly having to ask. Okay, theory is one thing. Let's see how these two different philosophies actually work in practice. We'll start with that first critical job, sending a new lab test from Hospital HKL over to IPR. With the push model, this is beautiful in its simplicity. It's incredibly direct. HKL has a new test, it just publishes a single message saying, "Hey, new test," and that's it. Its job is done. The middleware, Lisa, is just sitting there listening. It immediately grabs that message and tells IPR to register the new test. It's what we call a clean fire-and-forget handoff. So simple. Now let's compare that to the pull method. Whoa, it's a completely different story. This is way more of a conversation, a whole back and forth. First, Lisa has to ask HKL, "Hey, you got any tests for me?" If HKL says yes, Lisa then has to go back and ask, "Okay, great, now give me all the details for that test." Then after it sends the info to IPR, it has to circle back to HKL one more time to say, "All right, I've sent that one, we can mark it off the list." You can see, it's a lot chattier, right? Okay, so sending the test is just half the journey, right? What happens when the test is done? How do the results get back? So now let's look at the second critical workflow, getting that status update from IPR back to HKL. And this is just as important because HKL is sitting there waiting, needing to know what's going on with its patient samples. And you're probably not going to be surprised here. With the push method, it's, again, super direct and efficient. The moment a lab tech at IPR changes a test's status in their system, boom, their system publishes a little update message. Lisa, which is always listening, hears it instantly and tells HKL's system what the new status is. Simple, fast, and it all happens the moment the event occurs.
And with the pull method, yep, we see that same chatty pattern all over again. Lisa has to keep knocking on IPR's door, asking, "Any updates for me? Any updates for me?" When it finally finds one, it passes it along to HKL. And then, and this is the crucial part, it has to go back to IPR and say, "Okay, I've delivered that update, you can check it off your list now." It's that same cycle of ask, relay, and confirm.
So there you have it. We've seen both systems in action. One is incredibly direct, almost like a broadcast. The other is this constant conversation. And this brings us right to the heart of the matter, the architect's dilemma. If you were building this, which one would you choose? Well, like with most things in engineering, it all comes down to the trade-offs.
Okay, this table really lays it all out. Let's break it down. For speed, push is obviously faster. It's pretty much real time. Pull is always going to have a delay, right? You have to wait for the next pull. For responsibility, with push, the source system, like the hospital, has to be smart enough to actually send the event. With pull, all that responsibility is on the middleman, on Lisa, to go out and get the data. Then there's communication. Push is fire and forget. You send the message and you move on. Pull is super chatty. All those calls to ask, fetch, and then confirm. And that leads to state tracking. With push, you don't need much. But with pull, you absolutely need those little flags like is sent and is synced, just to keep track of what's already been done. It's just more complex.
All right, we've seen the workflows, we've analyzed the trade-offs, so let's get to it. What's the final verdict here? Which approach should our hospitals actually use?
You know, after seeing how clean and simple the fire and forget push method is, compared to all that back and forth chattiness of pull, you'd be forgiven for thinking there's an obvious winner. It seems pretty clear-cut, right? But is it really?
Well, the truth is, there isn't one. There's no single better architecture here. It's not about better, it's about fit. It's about what your system needs the most. Push is fantastic when what you need, above all else, is speed. Think about a stock ticker. You want that info instantly. But pull gives the central system, Lisa, something really valuable. Control. Think about it. What if hospital IPR suddenly gets overwhelmed with tests? With a pull system, Lisa can just slow down. It can ask for updates less frequently, acting like a brake and preventing the whole system from crashing. And that level of control can be incredibly powerful.
And that really leaves us with the one fundamental question that every system designer has to ask themselves. Is your system built to notify, or is it built to be asked? Do you want your components to be proactive, shouting out news as it happens, or do you want them to be more passive, just waiting for someone to come and ask for an update? The answer to that question, well, that's what will point you to the right architecture every single time.